March 17, 1943. In the unforgiving expanse of the North Atlantic, 400 miles south of Iceland, convoy HX-229 fights its way through 15-foot swells. It is a vital lifeline. 41 merchant ships bearing 140,000 tons of cargo for besieged Britain, aboard the Liberty ship SS William Eustis. 28-year-old cook Thomas Tommy Lawson performs the mundane task of washing dishes as the vessel rolls violently. On the bridge above, Captain James Bannerman scans a gray horizon, certain that beneath the waves, the U-boats are already listening. His fears are justified. Submerged 600 yards off the convoy's port beam, Captain Lieutenant Helmut Manzek sits in the control room of U-758. His hydrophone operator, headphones pressed tight, whispers a chilling report. Contact bearing 280. Multiple screws, heavy machinery. Estimate 40 vessels. Manzek allows himself a smile. The Wolfpack has its target. What none of these men can know is that an extraordinary secret rests with the ship's cook, for Tommy Lawson has noticed a peculiar acoustic anomaly in the sound Liberty ships make underwater, an observation that will change the Battle of the Atlantic. First, however, comes disaster. Over the next 6 days, convoys HX-229 and SC-122 will be savaged, losing 22 merchant ships and 300 seamen to the deep. It is the worst convoy catastrophe since 1942, a battle Admiral Karl Donitz, commander of Germany's U-boat fleet, would call the greatest of all time. The numbers tell a devastating story. In March 1943 alone, U-boats sink 567,000 tons of Allied shipping. At this rate, Britain has just 3 months of food remaining. As Prime Minister Winston Churchill would later write, the only thing that really frightened me during the war was the U-boat peril. Germany's advantage was its brutally effective hydrophone technology. U-boats could detect a convoy's propeller noise from 80 nautical miles away, while a ship's unique sound signature acted as a beacon for torpedoes. Allied countermeasures, zigzag patterns, radio silence, ASTIC sweeps, were failing. The convoys were simply too loud. Hunting in wolf packs, U-boats would descend to 400 feet, go silent, and listen. The solution would not emerge from an engineer or a scientist at Naval Headquarters in Liverpool, where Western Approach's command had been fighting this war for 3.5 years. It would come from a merchant cook who had dropped out of school at 14. By 1943, the Battle of the Atlantic had become a desperate technological duel. The Allies deployed every weapon in their arsenal, yet the U-boats remained a mortal threat. In 1941, the Royal Navy had equipped its escorts with ASTIC sonar, a system that could detect a submerged submarine at 2,500 yards. But its effectiveness was limited. The active sonar beam was a narrow cone, and U-boat commanders quickly learned to attack from the stern or the beam, remaining invisible. Worse, ASTIC was blind to surface U-boats attacking at night, the signature tactic of the wolf packs. A year later, scientists of the Admiralty's research laboratories developed high-frequency direction finding, or HFDUF, to pinpoint U-boat radio transmissions. While brilliantly effective at locating submarines that broke radio silence, its advantage was fleeting. Once a wolf pack made contact with a convoy, it ceased transmitting, switching to silent listening. Meanwhile, the Allied ships broadcast their own position with every turn of their propellers. This was the acoustic signature problem, an enigma that cost the Royal Navy £8.7 million, the equivalent of over $500 million today. Professor Patrick Blackett, the director of Naval Operational Research, stated in a classified paper that the noise from merchant vessel propeller cavitation and machinery resonance created underwater sound profiles detectable at extreme ranges. He concluded that without a fundamental hull redesign, impossible during wartime, convoys would continue to announce their positions to enemy hydrophones. The expert consensus was grim. A merchant ship could not be made quiet enough. In a memo dated February 14, 1943, Dr. Harold Burris, the Admiralty's chief naval architect, detailed the physics. A Liberty ship's massive 15-foot diameter propeller, rotating at 76 revolutions per minute, created a torrent of collapsing cavitation bubbles. This generated a broadband acoustic energy signature across the 1 to 100 kilohertz frequency range, precisely what German hydrophones were optimized to detect. Silencing this roar would require complete propulsion system redesign. 6 months of dry dock time per vessel, and manufacturing capabilities the Allies simply did not possess. The stakes were existential. Britain imported 2/3 of its food and all of its oil. By March 1943, German U-boats were sinking ships faster than Allied yards to build them. For 3 consecutive months, tonnage lost had exceeded tonnage launched. At the Atlantic Convoy Conference in London on March 4th, Rear Admiral Leonard Murray, commander of the Royal Canadian Navy's Atlantic Forces, delivered a blunt assessment. Gentlemen, we're losing. Our escorts can't hear the U-boats because of our own convoy noise. The enemy can hear us from 50 miles away. Unless we solve the acoustic detection problem, we will lose the war. By the summer of 1942, the Allied merchant fleet was broadcasting its own death warrant across the Atlantic. A British naval engineer proposed a solution, installing sound-dampening mounts on every piece of machinery. The cost was staggering, $250,000 and 12 weeks in dry dock per vessel. With 2,400 ships in the convoy system, retrofitting the entire fleet would take an impossible 138 years. An American scientist suggested coating hulls in sound-absorbing rubber, an idea that failed catastrophically in testing. The rubber degraded in salt water, created immense drag, and cut ship speeds by 3 knots, making them even more vulnerable. A Canadian engineer's proposal to redesign propellers, while brilliant in theory, was utterly unfeasible, requiring the retooling of every foundry in North America and the scrapping of 14,000 existing propellers. On March 15, 1943, Allied naval commanders formally accepted a grim reality. There was no technological silver bullet. The convoy's acoustic signatures were an unsolvable problem. The only remaining strategy was one of attrition: add more escorts, provide more air cover, and pray that enough ships survived to keep Britain in the war. Yet, 800 miles to the west, aboard a Liberty ship battling a North Atlantic gale, a ship's cook was about to prove the world's foremost experts wrong. Thomas Patrick Lawson possessed no engineering degree. Born in South Boston in 1915, he had dropped out of school at 14 to support his family during the Depression. After years as a line cook and a galley hand on coastal freighters, he joined the U.S. Merchant Marine at 26. His motivation was not heroism, but the promise of $125 a month, triple his Boston wages. His captain's evaluation from June 1942 was dismissive. Lawson, TP, ship's cook. Adequate performance, no leadership potential. Recommended for galley duties only. After 3 harrowing convoy runs to Liverpool aboard the SS William Eustace, Lawson developed a peculiar habit. He began spending his off-watch hours in the ship's engine room, simply listening. The crew thought him mad. "Tommy's going to get himself killed down there," remarked first mate Robert Chun. "That engine room is hot as hell and twice as loud." But Lawson wasn't there for the heat. He was listening to the cacophony because he had noticed something no one else had. On February 19, 1943, in the mid-Atlantic, with the William Eustace sailing in the 63-ship Convoy C 118, a U-boat alert sounded. Lawson was in the engine room, crouched near the main steam line, when the ship's engineer, a gruff Scotsman named Donald MacLeod, shouted at him over the roar of the turbines, "Get back to your galley!" For a ship's cook named Tommy Lawson, the defining sound of a U-boat attack was not the initial blast, but the eerie silence that followed. When a torpedo struck a Vessel 2 columns over, Lawson observed a strange phenomenon to the hull of his own ship. As seawater flooded the crippled vessel, the telltale vibrations of its machinery, the very acoustic signature that U-boat hydrophones hunted, were suddenly muffled, then completely extinguished. This sparked a radical theory. What if a ship could deliberately flood specific compartments to create an insulating layer of water, effectively silencing itself? For 2 obsessive weeks, Lawson filled a notebook with diagrams of water-filled chambers and modified ballast tanks. But on his own ship, the idea was met with universal contempt. He was dismissed by his crewmate M'Leod, laughed at by the first mate, and politely rejected by his captain Bannerman, who advised him to leave the engineering to the engineers. On March 24, 1943, when a freighter William Eustace docked in Liverpool, Lawson took an extraordinary career-threatening gamble. He walked directly into Derby House, the nerve center of Western Approach's command, and demanded to speak to an admiral. He was promptly arrested. As two Royal Navy Shore Patrol officers escorted him from the lobby, Lawson's desperate insistence about having an idea to reduce convoy noise was overheard. The voice that stopped him belonged to Commander Peter Gretton. At just 29, Gretton was a battle-hardened escort group commander, exhausted and furious after losing 13 merchant ships to wolf packs while protecting convoy ONS-5. Desperate for any edge, he listened as Lawson explained his theory of water-dampening machinery vibrations. When the cook finished, Gretton's arms remained crossed. "That's the most ridiculous thing I've heard this month," he stated. The concept was deceptively simple: acoustic insulation. Lawson proposed that by strategically positioning water-filled chambers against the ship's loudest components, the engine mounts and propeller shaft, they could use the water itself to absorb the telltale vibrations. On March 25, 1943, at the HM dockyard in Liverpool, Captain Gretton led Lawson to the corvette HMS Sunflower, then in dry dock. This would be their secret laboratory. Over 3 days, Lawson, Gretton, and the Sunflower's engineer, Lieutenant James Whitby, jury-rigged a prototype. In a flagrant breach of regulations, they welded empty oil drums around propeller shaft housing and filled them with seawater. On March 28th, they ran their first test in the Mersey River. The submarine HMS Trespasser, a co-conspirator in the unauthorized trial, submerged 500 yards away. The results were immediate and damning. Trespasser's captain signaled that he heard the Sunflower's engine noise and propeller cavitation as clearly as ever. The experiment was a failure. As Whitby muttered about the futility of the idea, Lawson spotted the flaw. The crude drums, filled in dry dock, had leaked through their seams. A tense confrontation followed. Gretton, facing the real possibility of a court-martial for modifying a warship without authorization, was ready to abandon the project. But Lawson countered with a stark reality. With U-boats sinking 20 Allied ships a week, the cost of inaction was losing the war itself. Gretton relented, granting him 3 more days. The team worked around the clock, replacing the leaky drums with properly welded steel chambers and adding water-filled rubber bladders against the engine mounts. They had, in effect, invented what naval engineers would later call liquid acoustic dampening. On April 2nd, they conducted a second test. This time, Sunflower moved at full speed, with Trespasser submerged 1,000 yards away. Minutes stretched into an anxious silence. Finally, the submarine surfaced with an astonishing report. Its hydrophones had tracked the Sunflower perfectly until, at a range of 400 yards, the corvette had simply vanished into the ambient noise of the ocean. Lawson's theory was no longer a cook's fanciful idea. It was a war-winning breakthrough. On April 3, 1943, within the austere confines of an Admiralty boardroom in London, an emergency meeting was underway that would challenge the very foundations of naval doctrine. Commander Peter Gretton had requested the audience with Rear Admiral Max Horton, the formidable commander-in-chief of Western Approaches and a legendary submariner from the First World War. To the palpable disbelief of the Admiral's staff, Gretton was accompanied by Lawson, a 28-year-old American merchant seaman, a cook. When Horton entered with the senior officers, he was joined by Dr. Harold Burroughs, the same naval architect who had previously declared the concept of acoustic dampening to be an impossibility. Undeterred, Gretton presented the results of an unsanctioned test. The data was staggering. A ship's hydrophone detection range had been reduced from 12 miles to a mere 400 yards, a 97% reduction in its acoustic signature. The room filled with incredulous objections. Dr. Burroughs immediately dismissed the findings as preposterous, condemning Gretton for conducting unauthorized modifications based on suggestion of a civilian cook. Gretton's retort was swift. "A cook who understands acoustics better than your entire department." Captain Edmund Rushbrook, the director of naval intelligence, intervened, accusing Gretton of reckless experimentation. But Gretton cut him off, questioning what exactly was being compromised. "Our current system of letting U-boats hear us from 50 miles away?" A tense silence was broken by Admiral Horton, who raised a hand and turned his attention directly to Lawson. "Explain it to me," he commanded. Simply, Lawson explained the core principle. Ship machinery creates vibrations that travel through the steel hull and into the water. By strategically positioning sealed, water-filled chambers around engine mounts and propeller shafts, one could create acoustic barriers that absorb the vibrations before they escape into the ocean. Dr. Burrows scoffed, citing basic engineering principles about weight distribution, stability, and corrosion. One test, he insisted, under controlled conditions is hardly conclusive. As Captain Rushbrook began protesting the logistical nightmare of retrofitting hundreds of ships, Gretton interrupted with the brutal reality of their situation. The modifications were based on the fact that in March alone, the Allies had lost 567,000 tons of shipping because German U-boats heard them coming. Based on the fact, Gretton concluded, his voice low and firm, that if we don't do something different, we lose this war by autumn. The room fell silent. Within the Admiralty, the proposal was met with a wall of institutional skepticism. Dr. Burrows, representing the engineering establishment, laid out the seemingly insurmountable obstacles. Retrofitting 2,400 merchant ships was, he argued, a logistical impossibility. The nation's dockyards were already strained to their breaking point, and every ton of steel was precious, earmarked for the vital construction of escort vessels. His estimate was a minimum of 6 weeks per ship, a timeline that would render the project useless. But into this pragmatic assessment, a quiet voice interjected. It was the inventor, Lawson. The prototype on the Sunflower, he explained, had taken a mere 3 days. His concept was not complex engineering. It was a matter of welding sealed chambers around existing structures and filling them with water, a task any dockyard crew could perform and any ship's engineer could maintain. The debate intensified. Captain Rushbrook voiced the fears of command. If they diverted precious resources to this experiment and it failed under combat conditions, they would have squandered weeks they simply did not have. Commander Gretton's retort was bleak and absolute. If we don't test it, we've already lost. The decision fell to Admiral Horton. After a long silence, he turned from a window overlooking the Thames. The gamble would be taken. Commander Gretton was ordered to retrofit 6 merchant ships assigned to convoy on 184, departing Liverpool in just 8 days. Lawson would supervise the installation. Dr. Burrows would provide technical support, however reluctantly. The stakes were made brutally clear. If the system failed, Gretton would spend the war commanding a minesweeper in the Orkney Islands. To Lawson, the Admiral's words were a mixture of hope and warning. I don't know if you're a genius or a madman, but I do know we're desperate. Don't make me regret this. Between April 11th and 18th, 1943, within the Liverpool docks, Lawson's theory was put into practice. 6 ships, the SS Daniel Webster, SS James Herod, SS John Davenport, SS Samuel Eliot, SS Benjamin Ide Wheeler, and Lawson's own vessel, the SS William Eustace, received the modifications. The installation was brutally simple. Teams welded 24-inch diameter steel chambers around propeller shaft housings and fitted water-filled rubber bladders against engine mounts. The total added weight was 18 tons per ship, the installation time just 64 hours. Onlookers were unimpressed, with one naval engineer muttering that it looked like someone jury-rigged a plumbing system into the engine room. But the hydrophone tests were undeniable. Before the refit, a Liberty ship's acoustic signature was detectable at 11.7 miles. Afterward, that radius shrank to just 0.4 miles. The ships had become 29 times quieter. On April 22nd, convoy on 184 steamed into the Atlantic, carried with the fate of a desperate experiment. As the convoy departs Liverpool, it is more than a lifeline. It is a floating laboratory. 43 merchant ships steam in 9 columns. A vulnerable city of steel shepherded by a thin screen of 6 corvettes and 2 destroyers. Dispersed throughout this formation, 2 to starboard, 2 to port, and 2 in the center, are 6 specially modified vessels. Unbeknownst even to the convoy commodore, a high-stakes experiment is underway, designed to unfold under the brutal crucible of real combat. They are being watched. German naval intelligence has tracked their departure, and across their expected route, the 37 U-boats of Wolfpack Mesa had deployed into a deadly picket line. On April 25, 1943, deep in the mid-Atlantic, the hunt begins. Aboard U-264, Captain Lieutenant Hartwig Look studies his charts. For 6 hours, his hydrophone operator has been tracking the convoy, but the contact is baffling. The signal is intermittent. Some ships register as deafeningly loud, while others seem to vanish. Intermittent? That's impossible. Looks frowns. Either you hear a convoy or you don't. His operator confirms the anomaly. Some signatures are clear at 40 kilometers, while others disappear at 5. Ordering his boat to periscope depth, Look sees a sprawling convoy, but the visual evidence only deepens the mystery. His hydrophone should be screaming with the noise of 43 ships, yet they are tracking only 27. He quickly deduces that 10 are simply too distant for detection. But 6 ships, scattered throughout the convoy, are generating no acoustic signature at all. They are ghosts in the water. Confronted with this acoustic paradox, Looks makes a decision that will inadvertently save Allied lives. He will target only the ships he can hear clearly. On April 27th, 600 miles west of Ireland, Wolfpack Mesa makes contact. Over 18 savage hours, they sink 9 merchant ships, a brutal loss of 47,000 tons of cargo, consigning 3,200 men to lifeboats. But amid the carnage, a critical statistic emerges. Of the 9 ships sunk, 0 were the modified vessels. The 6 ships equipped with Lawson's acoustic dampening system survived untouched, slipping past the U-boats like specters. When the battered convoy reaches New York on May 7, 1943, its commander, Gretton, immediately signals London. His message is unequivocal. Modified vessels showed 0 enemy engagement. Acoustic dampening effective under combat conditions. Recommend immediate fleet-wide implementation. By May 12th, the cold calculus of war confirms his report. The Western Approach's command runs the numbers. Before the system's implementation in March, the average U-boat detection range was 11.4 nautical miles, with a staggering 31% loss rate per convoy engagement. After its widespread adoption, from May to July, the detection range plummets to a mere 0.6 nautical miles, and the loss rate is slashed to just 4.7%. The experiment had been a resounding success. The results were immediate, and statistically, they were staggering. Acoustic dampening slashed merchant ship losses by an astonishing 85%, while the loss rate for attacking U-boats skyrocketed by 400%. The German submarine, a predator that once stalked convoys from the safety of 50 miles away, was now forced to close within half a mile to gain a firing solution, a suicidal proximity that brought it well within the detection range of ASTIC, radar, and the keen eyes of lookouts. The very foundation of Wolfpack tactics, which relied on coordinated attacks based on shared hydrophone intelligence, crumbled. The submarines could not attack targets they could no longer hear. This devastating new reality would be etched into German naval history in May of 1943, a month that would forever be known as Black May. Over those 31 days, Allied forces sank 41 U-boats, a full quarter of Germany's operational submarine fleet, while losing only 58 merchant ships. The architect of the U-boat fleet, Gross Admiral Karl Donitz, captured the sudden sense of despair in his war diary on May 24th. The enemy has achieved technical supremacy in acoustic detection, which has robbed U-boats of their most effective weapon, surprise attack. We can no longer predict attack positions. The old certainties have vanished. This high-level admission was echoed in the bewildered testimony of a captured German hydrophone operator from U-954, sunk on May 19th. "We could not understand what happened," he told his British interrogators. "Sometimes we heard convoy sounds from great distance. Other times, ships were practically on top of us before we detected them. It was as if the ocean had become silent. Behind this strategic reversal was a logistical triumph." By July 1943, 847 Allied merchant ships had received the acoustic modifications. As crews perfected the technique, installation time fell to a mere 48 hours per ship at a cost of just $20,000 per vessel, less than one-tenth the price of building a replacement. The impact from May through December 1943 was undeniable. Allied merchant losses fell to 329 vessels, down from 729 in the preceding 8 months. During that same period, 237 U-boats were destroyed, and an estimated 4,200 merchant seamen's lives were saved. The Battle of the Atlantic was far from over. It would rage until May of 1945, but the tide had irrevocably turned. The U-boats, once the Atlantic's apex predators, had become the hunted. In the post-war years, Allied commanders reflected on this critical shift. Among the many innovations that secured victory in the Atlantic, wrote Admiral Sir Max Horton in 1946, none were as simple or as effective as Lawson's acoustic dampening system. A cook with no engineering training solved a problem that baffled our best scientists. Commander Peter Gretton, in his 1964 book Convoy Escort Commander, offered a more personal tribute. Tommy Lawson never fired a shot in anger. He never commanded a ship, but he saved more lives than any captain in the Royal Navy. His genius was seeing what everyone else missed, that the solution wasn't more technology but better use of the ocean itself. The scale of this acoustic revolution was staggering. Between April 1943 and May 1945, over 20,000 Allied merchant ships and 164 Royal Navy escort vessels were fitted with the new dampening systems. The entire effort consumed a mere 51,000 tons of steel, less than what was required to build 7 Liberty ships, at a cost of £6.2 million, or roughly $400 million in today's currency. The system's effectiveness ensured its legacy. Post-war, it became standard equipment on all U.S. Navy surface vessels, evolving into the Prairie Massacre noise reduction system. While modern iterations use compressed air bubbles instead of static water chambers, the core principle of creating an acoustic barrier to mass machinery noise remains identical. Yet the humble hero of this story, Thomas Patrick Lawson, retreated from a history he had helped to shape, awarded the British Empire Medal in a quiet London ceremony in June 1945. He systematically refused all interviews and publicity. When pressed by the New York Times in 1947, he demurred, stating, "I just noticed something and mentioned it. Other people did the real work." Lawson returned to Boston, opened a small diner in Dorchester, married, and raised 3 children, never speaking of his contribution to the Battle of the Atlantic. His own wife remained unaware of the full story until 1978, when a British naval historian finally tracked him down. When Lawson died in 1991 at age 76, his obituary in the Boston Globe identified him simply as a retired restaurant owner and merchant marine veteran. It made no mention of the acoustic dampening system, the 4,200 lives saved, or the fact that a high school dropout with a notebook had changed the face of naval warfare. At his funeral, however, 3 elderly British naval officers, men who had survived the treacherous convoy runs of 1943, paid their respects. One of them placed a note in Lawson's casket that read, "Because of you, we came home." In 2011, the U.S. Naval Academy enshrined Lawson's story in its leadership curriculum, summarizing its lesson: innovation doesn't require credentials. It requires observation, courage, and a willingness to challenge expert consensus. Today, every surface warship in the U.S. Navy operates with direct descent into the water-filled chambers sketched in a notebook 80 years ago, a testament to the fact that victory can hinge on one person noticing what everyone else has missed.